Hi, today we're going to look at sum to infinity of a geometric progression. The sum to infinity of a geometric progression is very simple to obtain. What's the formula? The sum to infinity of a geometric progression, we have it as a all over 1 minus r. This is normally applied whenever the common ratio is less than 1. If the common ratio of a particular geometric sequence is less than 1, you can easily find the sum to infinity of that particular geometric progression. Now let's just go down with this particular example. Example here says 1. Find the sum to infinity of a GP whose first term is 3 and the common ratio whose first term is 3 and the common ratio is half. Find the sum to infinity of a GP whose first term is 3 and the common ratio is half. Solution. How do we get this? We are looking for the sum to infinity, which is unknown, of a GP whose the first term of the GP is 3 and the common ratio r is half. Now how do we apply this? Just getting down to your formula, you have sum to infinity. The sum to infinity is equal to a, the first term here is 3 all over 1. We have here as 1 minus the r, which is the ratio, is half. So sum to infinity here will be equal to 3 over 1 minus half here will give us half. We have it as sum to infinity of a geometric progression will be equal to, we have it as 3 divided by half, which is sum to infinity is equal to 3 times 2 over 1, and the result here is what? 6. So the sum to infinity of this particular geometric sequence is equal to 6. What if a question like this is given to you? If the sum to infinity of a GP is 12 and the first term is 4, find the common ratio. The question says if the sum to infinity of a GP is 12 and the first term is 4, find the common ratio. How do you apply this particular question? Under solution, you can just bring down what you have in the parameters. If the sum to infinity of a GP is 12, sum to infinity is equal to 12, and the first term of the GP is given to us as 4, find the common ratio. The common ratio is what we're looking for. We don't know the common ratio, so definitely we go down here to find the common ratio. We have it as sum to infinity. The formula, sum to infinity is equal to a all over 1 minus r. Therefore, the sum to infinity given to us here is 12 is equal to our first term a is 4 all over 1 minus r is what we're looking for. So what next? You cross multiply. You cross multiply here, have cross multiply. We cross multiply, we have it as 12 in bracket 1 minus r is equal to 4. So we have it as, make 1 minus r is the subject of the formula. Making 1 minus r is the subject of the formula, you divide both sides by 12. So 12 cancel 12, we have 1 minus r is equal to 4 by this will give us 1 over 3. Therefore, make r the subject of the formula. Making r the subject of the formula here, we now have it as, here should be 1. When this crosses the equality sign to give us minus 1 over 3 is equal to, when r crosses, we give a positive r. Therefore, here should be, the common denominator here is 3. We have 3 times 1 here is 3 minus 3 divided by 3 will give you 1. 1 times 1 is 1 equal to r. So 3 minus 1 here will give us 2 over 3 is equal to r. Therefore, our 2 over 3 cannot be equal to r. Rather, r will be equal to 2 over 3. I'm going to stop here for now. If you have any other question to ask on sum to infinity of a geometric progression or any other thing pertaining sequence, send it via my email address, which is on the screen. See you, and don't forget to subscribe. Click on the subscribe button to get more of my videos that do comes your way almost every 2 days. Thank you, and God bless you.